All right, I think we're gonna go ahead and get started here. So thanks everybody for coming out today. My name is TJ Van Tol, and I work as a developer advocate for Progress. And today I'm gonna be talking to you about something that I personally think is really cool, and that's building 3 applications from one single JavaScript codebase. And hopefully we'll have a little bit of fun as we go through this. But before we dive in, I've got 2 quick sort of just housekeeping type of things. The first is that we will be putting a recording of this webinar up on YouTube. Usually we do that within a day or 2 of these events. So if you do have any audio or video issues sort of throughout this presentation, make sure to check your email afterwards and we'll send you out a link so you can watch the full webinar in its entirety. The second thing is if you have any questions that come up sort of as I'm going through this, we do have some people on the line in the sort of questions pane in the GoToWebinar client. So if there's anything you want to follow up on, ask, feel free to jump in there and ask any questions and we'll get back with you and try to help you out, point you in the right direction. So with that out of the way, let's go ahead and get started. And this is a talk about building 3 applications. So I thought I'd start by just quickly clarifying what I mean. When I say building 3 different applications, I'm specifically talking about building for iOS. So building native iOS apps that can run and live on the iOS App Store, run on iPhones and iPads and iOS devices and such. Second, apps that work on the web, apps that you can access through a URL and view in a web browser. And third, native Android apps that can live on Google Play and that you can download and run on Android devices. And we'll be looking at projects that allow you to build for all 3 of these things simultaneously. And specifically, just to give you a sort of high-level overview of what we're going to be doing here, is I'm going to start with a little bit of a background. We'll talk about why would you even want to do this? Why would you build for 3 different application platforms? And after we go through some of the background, some of the why, some of the history behind this, we'll jump into some demos, which will be the meat of our presentation today. Just because I think it's a little bit easier to learn some of these approaches when you actually see them in action and sort of can judge them for yourselves as part of a sort of a real app development process. So we'll be looking at demos of 2 of the approaches I'll be talking about today. One is based off React Native, and the other is based off of NativeScript. Now I did say I was going to start with a little bit of a background here. And really what we're going to do is start with what I think is one of the more contentious debates that we've had in tech over the last decade, and that's web versus native. Basically, since the advent of devices like this, we've had a conversation of the tech world of, is it better to build apps that you build and deploy, that you distribute through the web platform, so browsers and such, or is it better to build native mobile applications for platforms like iOS or Android? Or if you go back further, that conversation would also include Windows Phone or BlackBerry or some of these other mobile platforms that have existed over time as well. Now, for me personally, I've had sort of an interesting relationship with this debate. I've sort of been all over the place. So I've been a long-time web developer. I've been writing JavaScript code for well over a decade at this point. And as such, I've been a pretty big proponent of the web. So I've written a lot, I've made a lot of videos like this, arguing in favor of the web, arguing in favor of developers, building and really embracing the web platform. But on the flip side, I've also worked quite a while as a developer advocate at Progress, where I've spent a lot of time working with developers and companies that build for iOS and Android directly. And I've seen a lot of the successes that these people have had and that how successful you can be building for native platforms also. So I've also got a lot of things I've written and published that are very much arguing in favor of native application development as well. So if you do view this as a debate, you can very much view me as a political candidate that's sort of swaying both sides of this argument because I've sort of been all over the place. But I will say that more recently, sort of because I've been a proponent for the web and native apps as well, my most recent stance, or what I argue for now, is that for companies, for developers, for really anyone that finds themselves in a situation where they are choosing between the web platform and native application platforms, that they might want to consider, or that I would argue that they should, try to build for both platforms at the same time. And really, that's what I'm going to try to prove to you today, that you might want to consider building your next application for the web and native simultaneously, and we'll look at some options to do so. Now, to support this argument, really, if you go back to the web versus native debate, In my time that I've spent with developers, sort of working around this problem, what I found is that even though this can be contentious, there are certainly people that are very much pro-web and people that are very much pro-native. But what I found is that even people on the fringe side of this sort of argument can agree on a handful of things. They can agree that there are certain advantages to each of these platforms. When you look at the native side, for example, we can accept that users just spend a lot of time in native mobile applications. It makes up something like 90% of internet time on smartphones is spent in apps rather than on the web. And actually, I've seen studies, if you take the internet part of that study out, so you just look at usage time, app time can be something like 15 or 16 times web time on certain devices. So it's pretty crazy just how much people use native mobile applications. And so whether we like to admit it or not, for a large chunk of users, these users are just accustomed to going to places like the iOS App Store, like Google Play, finding applications there, and using those applications on their device. Now, on the flip side of things, though, the web is really well known for its reach. There have been numerous studies that have shown that if you take the same application and you distribute it through native mobile platforms and web platforms as well, that web app is going to find more users. And if you think about it, that just sort of makes sense. When you develop for the web is a place that has no boundaries. Every device out there that gets sold today has a web browser, sometimes multiple web browsers, that users can use to find your apps. Whereas when you build native mobile apps, you're really segmenting your users. iOS users, if you build for the iOS App Store, you're only building for certain iOS users. Google Play does the same for Android. And the web is really the only platform that gives you that true universal reach and that ability to reach a whole lot of users. So if we go back to this debate, if we can sort of accept that each platform has its sort of own unique advantages, then I would argue, just to take this one step further, that suppose in a hypothetical situation here, that you are building your next application and you're doing so in an environment where you have no constraints. There's no timeline for you. There's no budget restrictions. You have a great staff, unlimited people to work on this. So of course, there's also rainbows and unicorns flying around the office as well. Well, I would argue that in this situation, because each platform has its own unique advantages, that you would of course build applications for each of these platforms. I mean, why wouldn't you? Why wouldn't you want to build the best possible experience for your users on all the platforms that they might try to utilize your app or your service? And I would submit as further evidence to this, if really everybody watching this, if you could just take a minute to think of maybe 3 or 4 services or applications that you use as part of your day-to-day life. So think about services you use for social media or music streaming or video streaming, email, maps, those sorts of things. I'm guessing that if you think of those 3 or 4 in your head, that those apps are probably available both on the web platform and native mobile platforms as well. In fact, when I look through lists of sort of the top 10, top 20 applications that are out there in places like the App Store and Google Play, those apps are pretty much universally available for both platforms. In fact, the only exceptions I could find to that rule, there are a handful of mobile apps that really utilize some mobile hardware feature and sort of really need that feature to be available. So, for example, Snapchat is native only because they need to use the device's camera in a non-trivial way. And Uber and Lyft for the other big exceptions because they need geolocation APIs that only native mobile apps can provide. But with a handful, if you take out those handful of exceptions, pretty much all major brands, major companies, major applications are already doing this. They're already building for all of these platforms. Now, of course, if you remember to what I said earlier, there's of course one major caveat that I offered for this entire conversation. I said if there were no budget restraints, resource constraints, those sorts of things as well. But of course, I'm assuming you watching this operate in some sort of reality that there are constraints. And I'm also guessing that you don't have YouTube or Twitter's budget to throw at your next sort of line or business app that you need to create. And really, to take a step back, this sort of a disconnect between your ideal situation where you'd like to be building for all these platforms, and the reality where you have all these constraints, is really what fuels this web versus native debate and this whole conversation. Because once you have these constraints in place, you have to start making hard decisions of which platform is better, rather than trying to build for all of these things at the same time. The good news is that this sort of disconnect between the ideal and reality has also led to a ton of engineering work being put in to try to make it easier for developers to actually build for both of these platforms at the same time. Now, there are a number of different solutions out there for doing this sort of thing. The two that I think are most popular, the ones that I'm most familiar with, and the ones that I'm going to be talking about today, are one that's based off of the React Native technology stack, and one that's based off of the NativeScript technology stack that I help work with at Progress. Now, I'll talk about these solutions in detail here in a second, but first, just for a little bit of background, if you are someone that has not dealt with React Native before, has not dealt with NativeScript before, both are projects that let you use JavaScript to build native iOS and native Android applications. So React Native is done by the React team at Facebook. NativeScript is done by the NativeScript team here at Progress. And I'll be talking a bit more. In fact, a lot of the demos are going to be about how these two different technologies are different. But for the moment, just know that each are ways of building native iOS and Android apps using JavaScript. And also, one of the more characterizing feature of each of these frameworks is that not only do you build native iOS and Android apps, but that you do so with native iOS and Android user interface controls. So the advantage here being that you get the sort of performance and UX that you would expect out of developing with native iOS and native Android tools, but you get so while still being able to develop these applications using JavaScript. Now, one major consequence of this, though, is in order to let developers build native iOS and Android sort of UIs for their applications, both of these frameworks sort of do not use web views, they do not use HTML, or they do not use the DOM in any way. And as such, the markup, the sort of code you actually write to build a screen like you see there, looks a little something like this. So here I have React Native code up in the top left-hand corner and NativeScript code on the bottom right-hand corner. And both of these are used to build up a relatively simple UI. And what each of these frameworks do, they have some code that basically parses this markup and turns it into native iOS or native Android user interfaces. Now, why this is important is if we sort of take a step back here for a moment and sort of discuss where we're at here. Remember, this whole talk is about building applications for 3 platforms simultaneously, for iOS, for Android, and for the web. And I've introduced NativeScript and React Native as ways of building for iOS and for Android. So the challenge here is going to be actually coming up with a way to build for the third platform for the web. And the real challenge is, if you look at this code here, this is not HTML you're writing here. So for each of these solutions, they're going to have to come up with some way of transferring or requiring developers to do something to turn this code into HTML code that can run in a web browser so that you can access all 3 of these platforms. Now, the UI is the main challenge because the cool thing is both of these technology stacks use JavaScript. And one of the cool things about JavaScript is just how cross-platform friendly it is. And JavaScript runs on the web natively, of course. So I mentioned 2 approaches, one that's React Native based and one that's NativeScript based. And what I want to do is actually show you a demo of building the same application using each of these approaches, just so you can get a sense of how each of them work. And I think what makes this conversation particularly interesting is that these 2 approaches actually take sort of completely different ways of handling getting to that web portion of the equation, how you get a web application out of something that's JavaScript native based. So we'll be looking at that. But before we dive into the actual demos of these 2, I'll give you a little just sort of brief background on what each of these approaches do or where they came from. So the first on there is called React Native Web. And React Native Web is a project that came out of the React Native community. It's actually by a developer named Nicholas Gallagher. He used to be at Twitter back when he started React Native Web, and he now actually works directly at Facebook. And it is very much a community project. React Native Web is on GitHub under Nicholas's personal GitHub repo, so it's not a sort of Facebook official thing, but it's still a fairly popular, sort of well-known approach within the React and the React Native communities. The second tool we'll be looking at is one called NativeScript schematics. It's something that we here at Progress have been working on. Now, just first of all, the term schematics actually comes from Angular. So in NativeScript, we offer first-class support for the Angular framework. We've been working with the Angular team now for a handful of years to make sure that the Angular experience in NativeScript is really good. And one thing that came out of that collaboration is that in NativeScript, we now support you can now build and run NativeScript apps using the Angular CLI. So the same Angular CLI that you would use to build web apps. Now, the term schematics that I mentioned earlier is actually a term that comes directly from the Angular CLI. Schematics is an API that is offered to extend the Angular CLI. And so what we've done at NativeScript is use those APIs to make it possible to use the Angular CLI to build for all three of these platforms. So, as I mentioned, the first solution we'll be looking at is React Native Web. The second is NativeScript schematics through the Angular CLI. And what I want to do is actually demo this. I think it's a little bit easier to see what these tools do if you see some code, see these things in action, sort of see how they work. And what I'll be doing with each of these frameworks is building a little simple sample app. If you know me, if you've met me before, you know that my sample apps tend to be a little bit silly, and also that I have a thing for Pokemon. So I'll be looking at just a really simple checklist app and keeping this thing purposely simple just so you can focus on how each of these frameworks approaches the problem of multi-platform development and sort of also compare and contrast the two approaches to building the same application. But I do want to make it clear real quick that even though what we're going to be building today here is very simple, that both of these tools have been used for very serious production apps and production tools. So if you look at React Native Web, and I'll point you at their GitHub repo here in a second, it's been used to drive Twitter Lite, so the mobile web version of Twitter, and they have some other showcases that they list on their GitHub repo. With NativeScript and Angular, we have a number of showcases. You can go to nativescript.org/showcases to check them all out. Probably the most widely used of them is an app called Portable North Pole. It's an app that gets multi-millions of downloads every holiday season. And if you have kids, it's sort of a fun app to sort of experiment with and try them out, especially since it's the holiday season right now. So I promised a demo. Let's actually look what these two frameworks or these two approaches to cross-platform development really look like in action. All right, so I switched over here to my browser and also my development environment, which I'll be showing here in a minute. And I've got up the first of our approaches, React Native Web. And this is the GitHub repo, which you can find at github.com/Nicholas, NECOLAS/React Native Web. And the GitHub repo is really the main place to go for React Native Web. It has information on getting started and some other documentation topics that we'll be talking about here in a second. But when you're starting, this quick start section is the main thing you'll want to look for. I'd actually recommend going with this Code Sandbox link. It's sort of an environment where you can try React Native Web out directly in your web browser. So it's great because you don't have to download anything. You don't have to set up anything locally. You can just get started using the tool right away. When you're ready to set up something a little more robust, you can read this Getting Started section. It'll tell you about how to download, how to get started, how to set up your local environment so that you're ready to build these sort of cross-platform applications. And what I've done is I've already downloaded one here and set things up. This is in the React Native folder I've got here on my local laptop. And if you're familiar with React, you'll probably recognize a lot of the file and folder structure here that I'm using to build this application up. If you're not, don't worry too much about that. This isn't a talk where I'm going to try to teach you sort of the in-depth inner workings of React. And the same is going to be true when we look at NativeScript and Angular here later on. What I do want to focus on is sort of the main component being used to build this app. And to give this a little bit of context, I'm going to head over to my command line here where I'm in this React Native app. And if I look at this repo, I've got a handful of scripts set to help me run this application, both for iOS, for Android, and the web. And I'm going to start by running this for the web, this command npm run web. Now, this will take a second to run. It's basically going to be building this thing under the hood and then firing this up on my device, or my browser, I should say. And you can see I see a little hi message, which is actually coming from my shared app file here over here. The other thing I'm going to do, you might recall from earlier, I also had an npm run iOS command set up for running this app on iOS. Now this command is going to take a little bit longer because what React Native is going to do is it's actually going to use Xcode to build a native iOS application for this app here I'm developing in Visual Studio Code. And it's going to launch it on an iOS simulator, which I've got over here on my other monitor here that I'll show in a second. Now what's cool is you'll see in a second when this app comes up is that this exact same component that I have here is going to drive both the web version of this app and the native iOS version, and it would also drive the native Android version if I started that up on that platform as well. Now, while we're waiting, I can actually already sort of point out the fundamental way that React Native Web approaches cross-platform app development. As you'll see, this component that you see looks like any other sort of React component, again, if you're familiar with the React ecosystem. But what you would not recognize, even if you're sort of a React Web expert, is the UI components that I'm using here to actually render the interface portion of this application. Because if this were just a normal web app here, I'd be using things like divs and spans and other HTML components here to build up my app. And instead, I'm using this sort of different vocabulary, safe area view, text. We'll see some other ones here in a minute. And these are partially unfamiliar because these components are actually coming directly from React Native. And what React Native Web is doing that's interesting is that it's taking these components that you write for React Native and directly outputting them in a web browser. And what this means is, now that my iOS build just finished there in the background, is that using the exact same code base, and this is one component that I haven't made any changes to, I'm able to render apps both on the web, which I see here, and also for native iOS using native iOS user interface controls. So this, I think, is pretty cool. It gives you a lot of power in terms of just how concisely you can build up your apps for multiple platforms. But of course, this app isn't doing anything at the moment, so let's start to build this into more of a complete application. So the first thing I'm going to do is go into this React hook. This is basically, you can almost think of this as sort of like an init function. And I'm going to paste in a little bit of code that's going to fetch some data. Remember that this is going to be a Pokemon checklist app, so I've got a quick little endpoint that's going to give me some static JSON data. And then I'm going to, in my component here, put in a little more of a complex markup that I'll talk about here in a second. And I've got one more function here to sort of help render out this UI. And what's cool is that you'll see, first of all, is you'll see my web app there updated automatically. I can go to my iOS simulator. I hit Command R in there and I see those changes in React Native for my iOS simulator here as well. And so the first thing is just how fast this is, right? I wrote some code in here, but I'm developing for multiple platforms simultaneously. So I see my changes on the web, and I also see it in this native application as well. Now you'll see I brought in some other UI components here as well, but the main thing I want to point your attention at here first is this fetch method. Now, if you're a web developer, you will recognize fetch. It is a method that is built into the browsers. It has pretty good browser support at this point, and it's just a way of making HTTP calls. But remember that this is a cross-platform app. Now, this is not a browser that you're seeing over here on iOS. So one thing that both React Native and NativeScript do is actually implement the fetch method with native iOS and native Android code. So without you necessarily having to know about it, React Native performed the exact same HTTP request here, but it did it using native iOS code to make the call. And NativeScript uses the same approach as well. Now, what's cool about that for you as sort of a multi-platform developer here is that it lets you write your code once. Again, I'm making one fetch call here in a way that's going to work for all of these platforms. Now, this app is looking a little bit better, but I want to make some additional changes here. So the next thing I'm going to do is go into the actual styling part of this app. And so if I go down to where React handles styling, I'm going to paste in a little bit of CSS code here and go ahead and save that. You'll see that my web app updates right away again. If I go ahead and Command R in my native app, I can see the changes there as well. Now, both React Native and NativeScript take what I think is kind of an interesting approach to CSS, or how styling is handled. Now remember, and I'm only going to say this about 10 more times, what you're seeing here is not a web app. This is not HTML. So the CSS that you see here in this component does not work exactly like, say, CSS on the web works. You couldn't just take, for example, some web CSS code here, paste it in verbatim, and expect it to work exactly as is. What each of these frameworks does is basically take the CSS rules you write here, parse them, and apply the native iOS and native Android equivalent of these rules. So when you write border color, for example, what React Native in this case is going to do is find the UI control that you're applying this rule to and call the underlying native iOS or native Android API to essentially paint a border of this color. And you'll see here in a minute, NativeScript actually takes the exact same approach. So this does mean at times that you might need to use, in fact, you will definitely at some point need to use different CSS for your web apps and for your native applications. And we'll look at some ways here in a minute that you can actually fork your code, like if you want to apply different CSS here for your components on the web versus your components natively. But a lot of the really common rules in both of these frameworks will work across both of these platforms. So things related to things like height, width, border, margin, padding, those types of really common rules, text size, font families, and those things are things that you can share across platforms. The last piece of functionality I want to add is the ability for users to actually tap on these items. So to do that, I'm going to add one more function here in my app that's going to allow users to select items. And I got to refresh to actually see that change. So users will now be able to select items both on the web and in this native app as well. But one thing is that if I refresh these apps, these selections go away. So the very last change I want to make is a way of actually persisting these changes, persisting the changes that the user has made within the app, that is. Now, this is another situation where you have multiple potential ways you can implement this sort of thing. Again, keeping in mind this is a multiple platform solution. The web platform and native platforms just have different ways of handling persistence. On the web, if we assume we're going to store this data locally in some way, the web has APIs like local storage and session storage and IndexedDB for handling this type of use case. Native apps, on the other hand, have things like you could store things using the file system. There are things like SQLite. You can even get into platform-specific things, like you might want your iOS app to write data to iCloud, for example, which is something you can totally do with this sort of setup and this sort of workflow. So you, as a developer, really have a choice at this point. You could use something like fetch, some sort of method that abstracts away all of the platform-specific differences, so something that gives you a single API that you can use on all three of these platforms. Or you can fork your code and essentially write different code for each platform to really do something very specific on each individual platform that you are building for. So what I'm going to do is for React Native here, we're actually going to show another one of these APIs that abstracts you from the platform-specific details. And then when we get to the NativeScript portion of this process here in a minute, I'll give you an example of how you might want to fork your code to handle this situation instead. So we're going to keep things simple for the React Native part of this. And so I'm just going to make a few quick changes. I'm going to introduce this array just to sort of store the user selections as they make them. And then when the user does make these changes down here, I need a little bit of code that just manages this array. So if it's a new selection, I need to push it into the array. If it's already in the array, I need to take it out. And then I'm going to use this API that's built into React Native and that React Native Web is going to make work on the web over here, called async storage. Async storage is really just a lightweight local storage wrapper. It's going to use local storage directly on the web, and it uses some sort of similar APIs over on iOS and Android. So when I save, when the user selects items, I'm going to save those changes. So the very last thing I need to do is when I retrieve this data on load, I need to add another little bit of code that actually gets that data so that when the app initially loads, as it does here, that my selections get remembered as I refresh. The same is going to be true if I go into here to the native app and do the same sort of thing. My selections are now remembered as well. Now, if you do want to get into forking your code, aka you want to do different things on the web and in your native apps, if you go back to the GitHub repo for React Native Web, you'll find that somewhere in here, yeah, here it is, there's this section on multi-platform apps. And this will walk you through how you can, for example, we talked about sort of forking your code for styling. There's little if checks you can do within your app. So you can say, if I'm running on the web, I want to use this style sheet, or maybe I want to use this value. And when I'm instead running on native, I use a completely separate file. For more significant platform differences, for times where you want completely separate implementations, something that's sort of beyond the scope of what you'd feel comfortable doing with an if check, React Native Web actually has a file naming convention. So you could put your Android code in a .android.js file. Same sort of thing with iOS and the web as well. You can see that this was actually inspired. We do something pretty much literally identical in NativeScript that we'll see here in a minute, but that's also an option for you if you're using React Native Web. So overall, I'll come back to this sort of architecture here in a minute, but I think React Native Web is kind of a cool way of generating a web application for the React Native app that you might already have. I think it's really cool how concise your code is. I mean, this is really just a single file that's 100-ish lines of code that's being used to generate, a simple but a functional little app that we're using here on multiple platforms, so over on the web and on iOS. The only tricky thing I found in my experimentation with this, if you've been wondering, because I certainly was, how React Native Web actually goes about generating this application, the source code it generates is kind of messy. So if I dig into something random here in the inspector, just to give you a sense of this, you can see how sort of clunky and verbose the markup for these individual UI components ends up being. Now, I know that I'm not supposed to know about this, right? This is a generated web app, so I'm not supposed to be digging in under the hood. But the web developer in me can't help but feel that this is a little bit clunky and messes with my workflow a little bit. For example, if you work like I do on the web, you might be used to going into your developer tools, whether those are Firefox or Chrome or whatever, and inspecting elements and starting tweaking with changes and whatnot. And you'll find that with React Native Web, that workflow, it doesn't really work because you're dealing with generated code here. So instead, you'll be doing things through your editor and messing with changes like this and seeing how it refreshes. And it sort of flips your workflow, at least if you work like I do. The other thing is, in some cases, I found it hard to customize things that were actually happening. Like, for example, if I wanted to mess with the scrolling behavior in this scroll view, it was sort of, I really didn't know where to start. So because this thing is generated, sometimes you give up a little bit of the control of how your application actually gets rendered. But as I said, it's still really cool that you get a functional web application out of really an existing React Native app that you already have. And really, that's React Native Web. And like I said, I will come back to this for a little bit of a conclusion here later on. But I do want to switch over to talk about the second of our solutions, and that is NativeScript schematics. Now, if you're interested in starting with this workflow using NativeScript for multi-platform development, what you'll want to do is head to docs.nativescript.org. This is the documentation homepage for really everything NativeScript. And if you scroll down, you'll find this section on code sharing directly on the homepage of the documentation. And this is going to walk you through really everything you need to know in a lot more detail than we're going to have time to cover today. But the most important thing to know, at least when you're sort of getting started, is that NativeScript schematics has two sort of global dependencies. The first thing is you'll need the Angular CLI, which you can get from NPM, and you'll also need NativeScript schematics, which you can also get from NPM as well. Both are quick NPM global installs. Once you have both of these, you'll want to use the ng-new command, which is just the Angular CLI's way of generating new apps. And you have to pass it this -- collection flag, which essentially tells the Angular CLI that NativeScript schematics exists and that you should use it as part of the app that you're building. So that's how to get started. And if you look at my editor, you might have noticed earlier that I've already got a NativeScript app in here. It's already sort of scaffolded out using these commands to save us a little bit of time. And like I said with React Native Web, I'll mention this again, if you are familiar with Angular, you're going to see a lot of things in here that are going to feel familiar to you. Really with NativeScript, we're just building on top of Angular's conventions and the way Angular approaches app development. So a lot of these files, a lot of the naming conventions here are things that are going to feel familiar. But again, if you're not an Angular developer, don't worry too much about the details here. What I really want you to focus on is the details related to code sharing and sort of the different approach we take with NativeScript for handling developing for multiple platforms. So with that in mind, I'm going to open the main list component for this application. This is sort of the main component that's going to drive this app, similar to the component I had up for React. Now, one difference here in NativeScript, we have our templates and our styling, our CSS in separate files. This is actually more of a sort of React versus Angular thing. With Angular, the convention is to put these things in separate files. React sort of encourages you to put them more inline. You could put them inline in an Angular file as well. There's different properties that you can use, but I'm trying to stick with the best practices here and just putting these things in separate files. Now, if I do look at these files, though, you can actually see the sort of fundamental difference between NativeScript and React Native, just sort of in the file structure being used. And specifically, note that I don't have one list component markup file and one list component CSS file, but instead I have two of them. You'll see here's the first list component file, the second, and the same is true for the CSS file as well. With NativeScript schematics, we decided to have you as a developer define the actual UI part of your application twice. Once for the web, which is going to be the versions of these files that does not have this additional sort of suffix here, and once for NativeScript, which are going to be the files with the .tns prefix that appear right before the end of the file extension. Now, the reason for this is we really want you to have as much control as possible over your UI, which you get for defining it for each platform. And in the process, you still do get to share a whole ton of code across these platforms. Now, to show that, I'm actually going to start to build up this same app. So I'm going to move my editor over here. Now, I'm going to bring my terminal back up. I'm going to stop some of my React Native processes here. So we'll kill this. Stop these as well. Head back into my NativeScript project. And I'm going to start by using the ng-serve command, which is going to allow me to run this Angular CLI project on the web. So I will bring this over here, get my browser ready to show the web app version of this. So if I refresh, I can see this hi string. And the next thing I'm going to do is use the NativeScript CLI here and use its run command, which is going to run this app on any connected iOS or Android devices. And I'm going to pass this additional flag that we introduced in the latest version of NativeScript, HMR, which is short for Webpack's hot module replacement, which, as you'll see in a second here, is going to give us a really sort of fast development workflow. So like with React Native, I'm going to give this a minute to run because this is actually going to be building for iOS. And I've also got an Android emulator up here as well. So we're going to try developing this app for 3 platforms at the same time. So hopefully the demo gods are with us today. But while this is running, I'll just open each of these template files so you can see the sort of different approach here in action. So we see this hi string on the browser, and this is actually coming from the list, the sort of non-TNS version of this HTML file for the web, which at the moment is a simple string, which we'll build this out here momentarily. Now on native apps, so we got the TNS suffix here, you'll actually see that we're using NativeScript user interface components that we in NativeScript know how to turn into native iOS and Android controls. And actually the Android version of this app is up here, so I can just drag this over here. And you'll see that this feels a little more React Native-y in terms of how you build up your applications. This label is going to be an android.widget.text view on Android. And over here on iOS, it's going to be a UI label that appears on the screen. So we'll try to get these positioned so we can do all of these 3 things simultaneously. Now, at the moment, it's kind of hard to see too much here. So let's again start to build up this app so we can see a little more of what this looks like. And like before, the first thing I want to do is actually bring in a service that can actually retrieve my data. So I've got a little Pokemon service here that's going to return the data that we need. And I'm going to go in here and replace this component with a little bit of code that's just going to call this service's get method to get some data and make it available on this component. So if you're familiar with Angular at all, you know that sort of items, properties that appear on this component, you can subscribe to in your markup. So what I'll do is the first thing is I'll head to the web version of my template. So I'll go into the web implementation here, and I'm going to spit out an unordered list that's going to show a list of actual items. So you'll see my Pokemon now appear on the screen. I'm binding to that list of data that I put in my component earlier. And then I'm going to head over to the NativeScript version of this, and I will use some NativeScript UI components. Oops, actually, Meant to put it below the action bar there. Some NativeScript UI components for building this list, and you'll see that pops up because of HMR really quickly there here on iOS and Android as well. Now you'll also notice that because in this case I don't have any CSS in here yet, the behavior of the default UI components on iOS for this UI table view here is to not sort of constrict the images within the cells, so it doesn't resize them at all, which is why you get this somewhat hilarious list of Pokemon that appears here that we're going to fix here momentarily. Now, like with React Native, with NativeScript, we have an implementation of CSS that is a subset of CSS that you can use to style these user interface controls. Now, unlike the React Native approach, what we'll do is, again, apply this CSS separately to this application. So I'm going to go here and go ahead and go to the web version of my CSS and paste in a little bit of web CSS that's going to make my checklist app here look pretty good. This is the same sort of CSS that I was using earlier. And then I'll head into the NativeScript version of this and paste in some NativeScript code that you'll see gets rendered pretty immediately here to my device and makes my app look good on those platforms as well. Now, one cool thing that I didn't mention earlier is that in NativeScript, we actually do support Flexbox directly. So even though we're not using web browsers here, we do actually have Flexbox working for native iOS and native Android user interface controls. So it can be a fun sort of way of sharing a consistent layout in your apps across both web and native. I should also mention here too that even though in this case I'm defining my CSS completely in separate files, we do have first-class support for Sass in NativeScript using this approach as well. It's actually back in here. It's a different flag that you provide through the CLI. And if you do that, you can share some of these constants. Like if you don't want to apply your, if you don't want to hard code your color multiple times, you could use Sass to sort of share some of these values, some of these common properties where it makes sense across your native and web apps. So let's bring the apps up here one more time, because the next thing I want to discuss is how to add the last piece of functionality to this app, and that's actually allowing users to select these Pokemon and for the app to remember them as well. Now, as you recall, for React Native, I said I was going to show a pretty simple cross-platform approach. So it's a single API that is going to work on all three of these platforms. And for NativeScript, I want to show you a little bit of a different approach that you can take. So to do that, I'm going to start by just going into my component here, and I've got a new method I'm going to write for when the user actually taps on one of these Pokemon. And I've got a method that I already implemented in my service called toggle selected. And if I bring up my service here, which I've got down here, first of all, in React Native, you remember we use the fetch method, and here we're using Angular's HTTP service to perform the HTTP call. Now this works in NativeScript because under the hood, we in NativeScript have actually implemented a version of fetch ourselves, much like React Native does, which is cool because it means libraries like Angular sort of just work on top of NativeScript without any additional changes. It means other libraries, so if you're familiar with NativeScript, we also have support for Vue as well. It means that Vue's service for performing HTTP calls just works as well out of the hoods, works out of the box. And we could use something like that for file storage as well to implement the sort of our requirement that we have for our application. But instead, just so I could show you a little different model of how you can implement this, I added this file called Pokemon Helper, just sort of a little helper class for dealing with some of these platform-specific differences. And in my service, I'm just calling off to the helper to read files and to write items when they change. And then in the actual implementation for this, you'll see that I have two different versions of my helper file. I have one for the web that all it's doing is basically acting as a lightweight wrapper of local storage. So I'm just getting items and setting items and doing a little bit of basic parsing. Over on my native side, though, I'm actually using one of the NativeScript built-in modules, which we call native TNS core modules. I'm using the file system module to work with the file system on my device. So when I save files, I'm actually writing files to the device. And the same thing when I'm getting that data, I'm actually retrieving data from that same file. You could see, though, how this model can be used for any number of things. If I wanted to do something more complex here, maybe switch the native side over here to using SQLite, I'd have a nice little place to put that logic while making sure that my web app still works. Or I could use this same sort of model of application development for even simple things. Like, for example, one thing I commonly need to do in native apps is sort of mess with the status bar in some sense. Sometimes in applications, you want the status bar to go away. Sometimes you need it to be a different color to match your UI. And that's something that you can do in native apps. Both iOS and Android have APIs for handling this sort of thing. But the web, on the other hand, does not. If you're in a web app, you have no control over the status bar that appears on the user's device. So one thing you could do is you could create a helper file for dealing with the status bar. And the sort of web version of your helper could just be a pass-through, something that makes sure things still work at compile time. And the native part of this helper, or for the status bar helper, could do whatever is necessary on iOS or Android to sort of configure these apps to meet your needs. Overall, what NativeScript and really also React Native do is give you a way for building for all three of these platforms while still allowing you to really leverage the best of what these platforms can offer. For example, for my web application here, I could easily make this into a progressive web app. I could add a service worker, I could add a web app manifest file. I could use existing extensions to the Angular CLI to do this. There's nothing special that we're doing in NativeScript that would prevent you from doing that. You could still build the very best web application you could using this approach. Similarly, on NativeScript, there's nothing stopping you from building the best possible native iOS and Android apps as well. Now, these are native apps. They are using native UI. These are apps that can leverage really any native application API that's out there. In fact, one thing I didn't really talk about, but with NativeScript, we actually have the ability to let you use native iOS and Android APIs directly through your JavaScript code. So any API that exists on these platforms is something that you can just directly use in iOS and Android without breaking your web app in any way. And it really goes further than this too. So another thing we have at NativeScript is the NativeScript Marketplace, which lists all the NativeScript plugins that both we and the NativeScript community have built. And there's a lot of these things, right? We're nearing 1,000 plugins that are out there, which means if you need easy ways to add functionality to your app, like let's say you need to work with the Facebook SDK, or maybe you need to use Touch ID or Fingerprint Auth or Face ID for your apps, or you need to leverage a service like Firebase or Kinvey within your apps. It's something that you can easily find on the NativeScript Marketplace. And what's cool is that this really gives you a powerful model to approach multi-platform development. To give you an example of this, suppose you're building apps for these platforms, right? So you got iOS and Android and the web over here. Suppose that you needed, the Pokemon Checklist app gets way more complex, and now I need a login form for this application. One thing you do is build your login screen as normal, build it in a way where you can share a lot of your code. So share your components, share your services, share your business logic, define your login UI for the web, then define your UI for your native apps, but in native, take advantage of, for example, doing Touch or Face ID for the UI on your native app. Maybe for your native app, you'd also want to leverage the native Facebook SDK to help your users log in. Overall, what this architecture does is really let you take advantage of the very best of what these platforms have to offer, while still offering you a whole lot in terms of code sharing. Remember that normally to build apps like this is normally something you'd have to jump into Xcode and learn something like Objective-C or Swift to write. Then you'd have to jump over into Android Studio and learn tools like Java and such to write an app like this. And instead, you're building all of this with JavaScript. And you're building this with a JavaScript framework you probably already know or at least could easily pick up. Now I want to show an actual concrete example of this. Now I could show something serious like how to build a login page, but again, I think I mentioned this earlier, but if you know me, my examples tend to be a little bit silly. So what I did is if I go into my component here, actually I'll show in my package, if I can manage to spell for you here today, my package.json file, that I've added a few plugins from the NativeScript Marketplace already to this app. Got the NativeScript audio plugin and the NativeScript explosion field plugin as well. And what I'm going to do is say, I could just toggle the selected Pokemon when the user actually makes an update in this app, but that's kind of boring. It's not really all that fun. So instead, what we're going to do is in this component, instead of just toggling this, we'll use a couple NativeScript plugins to do something fun. We'll play a little bit of audio, and then we have this explode method. So real quick, because the internet is magic, someone wrote an Android SDK for just basically making things explode. You can just pass it any arbitrary view, and it performs this explosion animation that's really kind of amazing. And because the NativeScript community is just as amazing as the internet, Brad Martin, one of our NativeScript developer experts, wrapped this Android SDK into an easy-to-use NativeScript plugin for just easily providing or easily performing explosions through a simple explode API. So it's really nice and easy to use. And the end result on Android here, now that this is refreshed, is now when I tap a Pokemon, instead of it showing up like this, what happens is I get to explode the Pokemon on the screen as well. So definitely a very practical example that you can take next back to your boss and explain all the great things that you can build with NativeScript. But like I said, keep in mind that you can do silly things with this architecture stack, and I do kind of encourage you to do silly things because it is a lot of fun to play with these APIs. But you can do a lot of serious things as well. So I've shown some examples, but I'll just mention a few more. You can leverage native maps. You can bring in robust camera APIs. You can work with geolocation as well. So there's really a lot that you can build that takes advantage of the best of what these application stacks have to offer and build the best possible apps for all of the platforms you need to build for. All right, switching over here. I just got a few quick things here to wrap us up here today. If you found this interesting and you're curious for next steps, again, the place to go for React Native Web, if you're interested in trying out that approach, is React Native Web's GitHub repo, which you can find through a simple Google search. And if you're interested in trying NativeScript schematics, the place to go would be docs.nativescript.org. There is a code sharing link that appears on the bottom left-hand side of the screen that'll give you the next steps you need to take. One other thing I want to mention is that even though I talked today about building sort of brand new apps taking this code sharing approach, we also have a separate workflow for migrating existing Angular web apps over to using this sort of multi-platform architecture. So if you're interested, it's in the same sort of section of the documentation. It'll walk you through the commands you need to take. But it's kind of a fun way that if you already have an Angular web app to add on existing native iOS and Android apps in a pretty seamless way. So finally, the last thing I want to discuss is, of course, a lot of people ask me just in terms of which should I pick. Should I go with React Native Web or should I go with Angular schematics for building for all three of these platforms? And the answer, of course, is it kind of depends. I obviously have my own biases here. I think a big part of your decision is probably at the framework level. If you're an existing React developer, I think you'll find a lot of the React-isms that are built into that architectural stack a little bit easier to get used to if you're already sort of familiar with that ecosystem. And the same is true over on the NativeScript side of things. If you're familiar with Angular, then it's going to be far easier to pick up NativeScript and Angular's approach of handling this code sharing situation. I think the trickier thing is determining which architecture is better in terms of how these frameworks handle the web part of the equation. Is it better to take React Native Web's approach and sort of generate a web application for you? Or is NativeScript's approach better in actually giving you control of having your UI for your web app and your native apps defined separately? And for that, I think this is a harder discussion. And I'm actually curious what you sort of think about this. Being a member of the NativeScript team, we're sort of curious in terms of what developers want in terms of building applications. So if you have feedback about this, feel free to, sort of reach out to us and help us guide where we take NativeScript next. I mean, my personal opinion on this is obviously I sort of prefer the NativeScript approach. That's why I work on the NativeScript project. I like having full control over my web app and don't have to work with some tool that's going to generate things for me. But I also see the appeal in the React Native Web approach, and I think it's really cool that you can generate a functional web app from an existing React Native app. So, like I said, let us know what you think. But overall, what I hope you get out of this more than anything else is that these tools are pretty cool. I think it's pretty awesome that we live in a day and age that as JavaScript developers, we can write applications for 3 platforms simultaneously. I mean, just a few years ago, it would have been unthinkable to try to build for the web and for native iOS and for native Android without learning a handful of new tools. And now we can do that, and we can do that and create incredibly powerful and really great apps for all these platforms at the same time. So if you have any final questions, again, I think we'll be sticking around in GoToWebinar here for a few additional minutes. If you have some final questions that you want to ask, feel free to hop into the questions pane. We can also continue this conversation on Twitter. I'm at TJ Van Tol there. You can also reach out to the @NativeScript handle. You'll get some of our broader team to hop in and answer questions as well. So thanks again for coming out. As a final reminder, this webinar was recorded and we will have it on YouTube within a few days. So if you want to get this and share it with some other people, see some of these things again, just keep an eye out for that. So again, thanks and have a good day.